Welcome back. We've created our X and our O objects. Now it's time to actually capture mouse clicks and position our X and our O objects on the screen. To do that, we need to update the board because the board is where we're going to do our clicks. And the method that we do for that, there's already a click method for our playfield graphics object. We do a click X, Y. This is the X and Y coordinate of the click on the object itself. And we want to convert that X and Y to a row and a column. And to do that, again, we do a little bit of math. We take the Y coordinate divided by the height of an individual cell, and we take the floor of that, which means we just round it down to the next lowest value, because we don't want to deal with fractional rows. We want to deal with integer rows. Likewise, the column is the X divided by the cell width. The other thing we're going to do is we're going to check to make sure that the value is between 0 and 2. For whatever reason, if you click outside of the box, maybe you click far to the right or something, we'll get values that are outside the bounds of our board, and we don't want to deal with that. We only want to deal with clicks that are within the realm of our board. And finally, we want to keep track of where that was captured, and so we add the variables last row and last column. And I'm going to put these in here to document these were captured. And I set all my initial variables when possible to null, as opposed to leaving them undefined, so I can tell the difference between something that is not assigned and something that's never been assigned. That works okay, but we still need to capture the fact that somebody clicks something. For now, I'm just going to do an alert. This is a bad practice in graphical user interface design, but we're just going to verify that this works, okay? It's just printing out the row of 0. See if we can get it to print out the column as well. Plus quote, comma, plus column. Let's get that up there. Okay, if I click here, it's row 2 and column 1. Yep. Okay, this looks pretty good. I'm going to take that alert out. All right, now that we've captured the last row and the last column that the user clicked, what do we do with it? We need to be able to position our objects based on that click. And that's where the go method for our tic-tac-toe game comes in. This is the heart of our application. Every tick in the playfield's system, it is going to call this go method for tic-tac-toe. And what we can do is we can say if the board's last row is not null, do something. In this case, I'm just going to alert the board dot last row plus a comma plus this dot board dot last column. And again, remember what we're trying to do here is to separate concerns. We don't want the board actually positioning things on the board. That's the role of the game. We're separating out that all the board does is it displays the model of our current board. And then what we're doing here is we're allowing the game, the tic-tac-toe game, to actually position pieces on the board. Let's see if this is going to work for us. All right. Yes, we've successfully captured the board position. Notice that once I clicked on it, the alert, it just keeps coming back. And that's because the alert is holding up the game. And then once I click OK, it moves forward. But then the playfield calls go like a quarter second later. And so it's constantly displaying this. Let's reset this board dot last row is equal to null. And let's see if we can reset this. All right. So now let's try again. When I click there, row comma 0, column comma 0, and nice. This is also a common problem that if you don't reset your values, you can find yourself running forever. Okay. Now, another thing that we should talk about here is, again, separation of concerns. Notice that I've got this underscore last row in here. I put all my local or instance variables, things that are part of the state of the object. I start it with an underscore so that it's clear that it's a value that is not handled outside of that object. And so we've broken our separation of concerns. I have my Tic-Tac-Toe class modifying the internals of the board class. And the reason we don't like this is that if for some reason I decided to change the internals of the board class, it would that change would ripple through the entire project. What I want to do now is control the manipulation of the internals of my board object by giving an access capability. In other words, I want to get the last row, get the last move, whatever that was. I'm going to add a get last move method that returns the last row and the last column from the board, the last place that the user clicked. And I'm going to call that method instead. And it is actually a little more intuitive. This particular check here, saying that I'm checking just the last row to see if it's null, is a little bit peculiar. It doesn't really describe what it is that we're doing. But if I can say go to the board and get last move, and it's not null, that makes a little more sense. So let's check to see if that works. It's at 0, 0, and 1, comma 2. This looks pretty good. And again, here I am manipulating the internals of the board object by manipulating its internal state. That's a very bad idea. Let's not do that. Let's create a method that lets us reset the last move. Okay, if I call cancel last move, it sets the last row and the last column to null so that when the last move is called, if it is not null, it returns a value, otherwise it returns null. And let's verify that continues to work. Okay, everything continues to work. That's fine. And again, we're displaying this internal value. This is not a very good idea. Instead, what we're going to do is, now you may notice that I've got this underscore on the board. This is my local variable, my internal state of the board. That's okay, but I don't want to call get last. I want to call get last move on that board. And then I'm going to say the last move. If there is a last move, then let's display that last move. That looks good. Now we're working. This is a much cleaner presentation. This actually says what we're doing. It says get the last move. If there is a last move, display the last move's row and last move's column, and then cancel the last move so that we don't have to see it the same move over and over again. Now let's see if we can actually position our X object. To do that, okay, and then of course we want to cancel our last move. Okay. Instead of displaying the row and the column on the screen in an alert box, we're now going to actually create an X object. There we go. And now we can position our X wherever we click it. Okay. What about O? Let's do the same thing. Let's make sure the O works. Yep. We're doing pretty well, but we don't have a concept of actually taking a turn. We're positioning our object, we're positioning our move, but it's not like we are at the point where we're actually playing the game, where one person makes a move, then another person makes a move. Let's start adding that capability in. But to do that, we need to have a turn, and I'm going to create variables called human and computer. Okay. And when we start the game, then the human will be first to go. Okay. And so what we need to do now is say if this turn is, whoops, we'll do one thing, else to do something else. If it's the human's move, we take that we get our last move, and then we create an X, and otherwise we're going to create an O. Okay. Let's give that a try. X. Oh, I forgot to switch the move, didn't I? All right, let's try that. Let's see. If it's X, we now want to say that this dot turn equals this dot computer. This dot turn equals this dot. Fresh. Now it's switching back and forth between X's and O's. We're in pretty good shape. We still have some problems here. What if I click again in the same place, right? It's not preventing me from moving twice. It's not double checking, and it's not stopping the game after the board is full. It's not checking to see if anybody's won. We have a lot more work to do here. Let's add some capability just to make sure that we aren't putting the same piece in a previously occupied square. And to do that, we need to add a method to the board object that checks to see that it's valid, a valid move. Is that really where that belongs? The board just keeps track of the model, the view of the board, and redrawing the board. We might be able to ask the board if something is on the board already, but really there's another object, which is the rules of the game. And I believe that the rules of the game are separate from the controller, the thing that manipulates where things go and who plays next. We're going to create a separate object that is just the rules of the game. Tune in for that.